So we were talking about global variables, and as you know that these are declared outside of any function and can be accessed anywhere in the program while using they can make debugging difficult because they can be changed from anywhere in the code. So it's actually not a good practice to declare everything global or public. So always look out for this, and it's not actually a suggested thing to do everything global or public, right? And then we have local variables. It is declared within a function or a block. These are variables which can be declared within a function or a block, and these variables are only accessible within that specific block or that specific function or with that specific scope. They help avoid conflicts and unintended interactions between different parts of the program. And then we have block scope. Some languages like C++ and JavaScript allow variables to be declared within a block like an if statement and restrict their scope to that particular block. This helps to keep variables tightly controlled and avoid unintended side effects. As we already discussed, the lifetime of the variable refers to the duration which it exists in memory, and this is closely linked to its scope. They may seem like simple concepts, but always remember that these concepts make up like 30 or 40%, even I would go on and say 50% of the programming concepts, because these things are used on a daily basis, on an hourly basis actually, or even you can say on a minute to minute basis. So please understand these concepts carefully and clearly, because this can make or break your time in software development, right? So I already told you the lifetime of variable refers to the duration during which it exists in memory, and it's closely linked to its scope. Then we have automatic variables, typically local variables that exist only while the function or the block is executing. They are automatically cleaned up once the function or block is executed. Then we have static variables. These retain their value even after the scope which were declared or which has been declared exited. They are initialized once only and persist across function calls. So this is actually for design patterns. Some of these design patterns use static variables. In languages that support dynamic memory allocation, variables can be created at runtime, and their lifetime is controlled by the programmer, right? So this is all something which we have already discussed, but the reason I am going through this again is to give you a quick glimpse and also to tell you that this is very important, very important. Please don't ignore it and go through these concepts rigorously, right? So have a discussion among your peers about potential issues that can arise from improper variable scope management. like accidental modification of global variables and how to avoid them. So this is an activity that you can do among your peers, among your age group, right, or in your class, so that you can know, or even in your friends, so that you can get a better concept or a better grasp of the knowledge, right? So definition and importance, we have a lot of important factors. Mutability is one of them, and it is something, it's like if a variable can be changed after it has been assigned. For these variables, like mutable variables, can be modified after they are created. Like in Python, you can have items removed, changed, or added, or anything else after its creation. Immutable variables are the variables that are once assigned. The value of an immutable variable cannot be changed, right? So examples include strings, tuples in Python. Immutability can prevent accidental changes to data, which is especially important in multi-threaded programs where multiple parts of the program might try to change or might try to inherit or use dynamic programming to change the same data simultaneously. Some examples of mutable variables are lists, dictionaries, immutable strings, tuples, right? And impact on the program behavior. Choosing between mutable and immutable variables or types can have significant implications on program behavior. Immutable types can lead to safer or more predictable programs. Mutable is often necessary for flexibility and performance. So this one activity that you can do a case study, right? You can build a case study and the case study can be about everything, a scenario where using immutable variables prevented a bug, or consider how using a mutable variable might have caused issues, right? So let me type it down for you so that you can discuss this and do the case study. This is actually an activity that I'm giving you. Scenario. Right? So this is a case study that you can do among your peers or with your peers. Right? I think the microphone is a bit, I have to adjust it. Right? I think it's nice now. Yeah. So then we have collections and complex data structures. So collections allow you to store multiple values in a single variable which can be managed collectively. First we have arrays, fixed size collections of items usually of the same type, and they are efficient but less flexible than scripts, right? And less used actually for large purpose programming databases. And fixed size collections of items in array are usually of the same type. They are efficient but less flexible, right? So that's why lists come in. The dynamic collections that can grow and shrink in size are called lists. Lists are more flexible and can hold different types of data. Then we have dictionaries, collections of key value pairs, right? They are particularly useful for quickly retrieving a value when you know the associated key. So that's where dictionaries are used. These are some important collections and you should know about them. Then we have object and classes. In object-oriented programming, variables can be instances of classes known as object, right? And objects can have attributes, variables within the object, methods, functions within the object. The structure actually allows for modeling real-world entities more effectively. And then we have nested data structures. Variables can also hold complex data structures like a list of dictionaries or a dictionary of lists. So these nested structures are powerful tools for managing complex data. And you can do an hands-on example, do an activity, design a program where each of your friends can create a nested data structure like list of student records, each containing multiple fields, names, age, grades, right? Then we have some best practices in variable management which should be followed. First is obviously a naming convention, which I have already told you about, but just giving you an example, it's actually better for you and your future self, so that if you use consistent and descriptive names, it helps others and your future self understand what each variable does or represents. Like you are using employee salary instead of X, that makes the code more readable, right? What is int equals to 5? If I am instead of X I am writing here employee salary equals to $50K or whatever, right? So that makes the code readable and I can understand it. If I have 5,000, right, int x equals to 5,000. Now what is x and what is x which is 5,000? How do you know that this x is equals to 5,000 and what is this x? You can simply write salary or employee salary. So you write employee salary here, and it's self-descriptive of what the code represents. This int, this 5,000 as an integer which represents the salary or the employee salary, right? Now you know what it represents, and always try avoiding magic numbers. Magic numbers are hard-coded numerical values with no explanation. Instead, define them as constant with descriptive names. Instead of using max users of equals to 100, always use description names using max users like this. Like if you have max users equals to 100, instead of just 100 makes the code readable and clearer. Same with this employee salary equals to 5,000, right? Minimizing global variables is important. Global variables can lead to tightly coupled code, making debugging and maintenance harder. Where possible, use local variables to keep data encapsulated within specific functions or blocks. Then we have something on code readability and maintenance. Writing clear, maintainable code is critical for long-term project success and for your success as a long-term in your career as a programmer and long-term success. You need to write clear and maintainable code, and it's actually crucial for long-term project and your career success, right? And this includes but is not limited to proper naming, minimizing global variables, public variables, using comments to explain complex logic. This is actually a comment, right? So let me give you an activity. You can do this activity. You can review a piece of code with poor variable management and practices and suggest improvements. Focus on naming, scope, readability, and comments, right? Okay. Moving on, we have something which is known as optimization and coding. Like how do you optimize the code? Right? Common mistakes with variables is uninitialized variables. Using variables before assigning them a value can lead to unpredictable behavior, and always assigning a value to a variable so that it does not lead to unpredictable behavior. Something called as variable shadowing. It's actually when a local variable has the same name as a public or global variable. It can lead to bugs and confusion in the code compiler. There are type mismatches. Assigning a type value of one type to a variable of another type can cause type errors, right? Especially in strongly typed languages. Then we have debugging techniques, print statements, debuggers, debug.log or anything like that, and other tools can help you trace and fix issues related to variables. For instance, a debugger allows you to create a code by code line and inspect the current values of variables. This is actually how you add a debugger in Visual Studio. You can add a code breakpoint here. This is actually a breakpoint. It's in a comment phase, so it's very light red. But if this particular block of code is executed and it's called by the compiler, this breakpoint will stop the flow of code, which means after this code is executed, it will stop at here and it will tell you that this breakpoint is hit and this code is being executed or is being called or is being sanctioned or referenced. After this will be executed if you do continue here, right? So using print statement, debuggers and other tools, it can help you trace and fix issues related to variables. So a debugger allows you that, right? It allows you to go step by step through code, line by line, and inspect the current values of variables. Optimizing variable usage, efficient variable usage involves minimizing memory footprint, reducing redundancy, and like ensuring that variables are only as large as they need to be. Like for an example, using a smaller data type for a variable like a short instead of an integer in C++ can save memory in a large scale application, right? Or in C# you have a small character, you have a single character, you can use char instead of a string, right? So in some cases you may also want to optimize how variables are used in loops or the recursion statements or functions to avoid unnecessary calculations or excessive memory usage. Let's talk about debugging. What's the hands-on debugging? Provide participants with a buggy piece. So this is something, this is an activity. You do this. You provide a code where variable related issues like name shadowing or anything like that are causing errors. Identify them and fix those issues. This is an activity which is actually usually followed in interviews. Mostly interviewers can ask you to do this or even optimize the code while reviewing your code or what you do next, reviewing what you do next. So this is actually a very common practice. You should be aware of this. Then we have some real world application and advanced concepts about variables. Variables in different programming paradigm, right? So variables are used differently depending on the programming pattern that you are following. In procedural programming, variables are typically global or local to a function. They hold data that is manipulated through functions or procedures. In object-oriented programming, variables are often encapsulated within objects. These variables, known as attributes or properties, are tied to a specific instance of a class or are manipulated through methods, functions associated with an object, right? And then in functional programming, we have variables in functional programmings which are often immutable, which means instead of changing the value of a variable, functions return new values based on input, supporting a more predictable and side effect free coding, right? Then we have static typing and dynamic typing. Dynamically typed languages allow variables to change types at runtime, providing flexibility but at the cost of a potential runtime error. One of the common examples I can think of at the moment is Python, right? Then we have statically typed languages. Variables have a fixed type that is determined at compile time leading to fewer type related errors but requiring more careful planning. Some of the examples, common examples, TypeScript, Java, C++. These are statically typed languages. Then you have something called concurrency and variables. In multi-threaded or concurrent variables, variables can become a point of contention if multiple threads try to modify them. Let's say they have 1, 2, 3, A, B, C, whatever threads, and they are trying in multi-threaded and concurrent programming. Variables can become a point of contention if multiple threads try to modify them simultaneously. It's something similar to many people are coming towards you, and at the same time it can become a little bit of it can become very overwhelming, right? So this can lead to race conditions where the outcome of a program depends on the unpredictable timing of threads. Let's say something which needs to come in a sequence. The first 1, 2, 3, 4, the fourth one is coming first. So something you need to do, you need to tell something to the fourth person, something which the first person is telling you. Now the first person has not come yet, but the fourth person is coming first. So instead of going 1, 2, 3, 4 in a sequence, the first person, instead of going like this, that the first person is telling you something important, and then you're telling it after second, third and fourth person, you're telling it to the fourth person, right? Now the issue is, instead of going in this sequence, another thing has happened. Fourth has come first. Now you don't have anything to tell because nothing has been told to you by the first person, right? So this is important. So thread safety, we have some techniques like logs. For thread safety, we have techniques like logs, mutexes, atomic operations to ensure that only one thread can modify a variable at a time, preventing data corruption. Immutable and concurrency is using immutable variables in a concurrent environment can lead and can avoid many of these issues because their state cannot be changed after they are created, right? So let's recap what we have learned so far and summarize. I will summarize the key points covered in this session. So what are variables? Why are they important? Different data types and how they affect memory management. The significance of scope and lifetime, mutability and immutability and how it impacts program behavior, best practices for naming, managing and optimizing variables, real-world applications and advanced concepts like concurrency and different programming patterns, right? So I'm gonna give you a wrap-up activity to reinforce your learning. Have your friends write a short piece of code that applies what they have learned, or ask your friends to do this for you, that you write a code, write what you have learned, short piece of code that applies what you have learned so far, right? They might give you something like create a simple program that is a mix of local, global, public variables and employs both immutable and mutable data structures. our handles data in a multi-threaded environment, and then we can you can share your insights about why you did what you did, right? You can do a discussion with them and tell them why you made these choices, so it can be somewhat of an engagement policy for you, right?